A very good morning, students. In this video, we will be discussing the selection sort algorithm. Selection sort works by selecting the smallest element in the list and placing it in its proper position. So, let us look at the selection sort algorithm. As we have discussed, we select the smallest element and place it in its proper position. If we remember this crux of the selection sort, understanding the algorithm will become very easy. So, let us look at the algorithm. The algorithm is going to receive the array A with size n, and we are going to have two for loops in this algorithm. So the first for loop will run from 1 till n minus 1, and the logic behind it is that if we sort in a list of n elements, we sort n minus 1 elements, the nth element will automatically get sorted. Therefore, we run the loop from 1 to n minus 1. Now, location is the location of the minimum element that we have found till now in each pass of I. Pass of I means each time the I is going to take a new value, we have to find that if I is 1, we will find the first smallest element. If I is 2, we will find the second smallest element. If I is 3, we will find the third smallest element. And whatever is that smallest element, its location we will keep in the LOC variable. And then there is another for loop in which we will compare each of the jth element with the LOC element, and if the jth element is smaller, we will update the LOC to point towards that j. So j is going to proceed from I plus 1 till n. So LOC is going to be the ith element, and the element next to this ith element is I plus 1. So j will start from a location immediately next to the ith element. So I plus 1th element will be your j, and it will go till n. And what we will do here, this LOC, A of LOC we will compare with A of j. If the element at the selected location is more than the A of jth element, then we will update the location to point to the jth element, because now this jth element is smaller than the element at A of location. So j will be stored in LOC. So at the end of this j loop, we will find the location of the smallest element and we will store that in LOC. And after the end of this loop, we will go and swap the element at I with the LOC. So what we are doing in this algorithm, first of all, we are keeping the ith element in LOC, and then we are finding the smallest element in the array and keeping its location in LOC, and then swapping the element at LOC with ith element to get the element at LOC to its proper position. Let us look at an example. Suppose we have the array with indexes 1, 2, 3, 4, 5 and the elements are 15, 12, 13, 17 and 11. Now I is going to be 1 and j is going to be I plus 1, which is 2, and LOC is going to be I, which is 1. So now LOC is this and j is this element. So we compare, is 13 less than 15? It is true. So what we will do, LOC will be updated to position 2. Then we will compare. Now the LOC element is which one? LOC element is 13. So we will compare this jth element 12 with 13. Now 12 is less than 13. It is true. So we will update LOC. Then we will compare this new LOC, which is 12, with 17. So 17 is less than 12 is false. Then we will compare 11 with 12 and we will find that 11 is smaller than 12. So we will update the LOC with 5. Now what we will do, we will swap this LOC element, which is 11, with the ith element, which is 15. So we will swap A of I with A of LOC, and what we will get, 11 at the beginning and 15 in the end. So we see that the smallest element has come to the beginning of the array. Now we will increment the LOC by I by 1. So we will point towards the 13. So I will become 2, J will become I plus 1, which is 3, and LOC is also 2, which is I. So now this 13 is compared with 12. Now 12 is less than 13, so LOC is updated to the index of 12, which is 3. Then 12 is compared with 17, 17 is not smaller. Then with 15, so LOC will remain 3, and we will swap this 12 element with 13 element. So this swapping will take place. Now we have 11, 12, 13. So first two elements are already sorted, and by chance in this example the next element is also sorted. So now I will become 3, J will become 4, and LOC will become 3. Now this 13 is compared with 17. It is not smaller. Then 13 is compared with 15, and 15 is not smaller. So no change will happen in the array. Then I will increment by 1. I will become 4, and J will become 5. Now 17 is compared with 15. Now 15 is smaller, so LOC, which was 4, is updated to 5, and then ith element is swapped with LOC element, and we get 15 and 17, and our array is sorted. So again we come back to the algorithm. In this loop we go from 1 to n minus 1. LOC will get updated in this jth loop by finding the smallest element. So A of LOC, it has to be, whenever we find a A of J which is smaller than A of LOC, we will update that J in the LOC. So by the end of this loop, we will have the smallest element's index in LOC, and then we will swap that element with the ith element, because that is the proper position of that element. I hope the syntax is clear, the algorithm is clear to you. A very easier version of this particular algorithm without using LOC is you run the loop from 0 to n minus 1, and then J will start from I plus 1. This I, it has to be small case. So I plus 1 till n. And if A of J is less than A of I, then swap A of I with A of J. So in this, what we are doing, if A of J is the smaller element than A of I, we are shifting A of J into A of I. And therefore, by the end, in the A of I, we will have the smallest element, and then we go here and increment I by 1 to find the next smallest element. So this is the easier version of the above algorithm. You can do it both ways. I hope the selection sort algorithm is clear to you. If yes, then do subscribe the channel and like the video. Thank you.